Welcome. This is Tober's class, Chapter 14. This will be lesson number 3. Chapter 14, Lesson 3. Energy. Any of the possible energies an electron may have in an atom is the energy level. There are 7. Those 7 also correspond to the periods of the periodic table. An orbital is a region where an atom where there is a high probability of finding electrons. Remember, those electrons are moving at close to the speed of light. So these orbitals, these places where they could be, they just give foggy shapes. And this one here happens to be an S shape, or a spherical. The valence electrons, you need to know, valence electron is an electron in the outermost energy level of the atom. So the outermost energy level of the atom. That's important, and that also gives it its ability to, whether it wants to chemically bond with something else. It gives it chemical and physical properties. The electrons are bound to the nucleus by an attractive force. As you know, the nucleus has protons and neutrons. Those protons have a positive charge, whereas the electron has a negative charge. It's attracted to the positivity of the nucleus. What holds the nucleus together? There's another force, stronger than electric force. It's called the strong nuclear force.
To explain everything we see or feel in our everyday world. But once we look inside the atom, it is immediately obvious that other forces must be at work in the universe.
By the mid-1930s, we knew that atoms are composed of electrons, obviously a nucleus of protons and neutrons. But there's a problem with this model because protons are positively charged. And so when they're close together, the electromagnetic repulsion blows the nucleus apart. That's not what happens, of course. There must be another force many times stronger than electromagnetism that glues the nucleus together. And that force is called the strong force.
The strong force is not only responsible for holding the nuclei of atoms together, and without that, every atom in the universe would just spontaneously explode.
So, this is important stuff. How atoms of various elements are different. The atoms of different elements contain different numbers of protons. That is correlated or related to the number that it is on your periodic table. Because the number of protons is important, it's called its atomic number. Please check your periodic table. How to read an element. Make sure you also write this in your word maps. So that number 8 there is the atomic number. The O is the element symbol. The oxygen is the element name. And the atomic mass is the combination of the protons and neutrons. The atomic number is equal to the number of protons. The number of protons is equal to the number of electrons. And the atomic mass is equal to the number of protons plus neutrons. So you can find how many protons it is if you take away the neutrons from the mass as well. Last one. Try this out on your own. Here I have carbon, and there is a card for carbon up there. It's number 6 on the periodic table. Its atomic mass is 12.0107. So the number of protons, of course, 6. It has 6. Its atomic number is 6. Electrons, same as the number of protons, so it should be 6 as well. And neutrons is the atomic mass minus the atomic number. So 12 minus 6 gives us 6. All right, so that's the end of this lesson. Hopefully you wrote this down.